Hey, hello friend. So today I'm going to solve one problem from Leetcode, that is problem number 779, kth symbol in grammar. So this problem I will be solving using recursion. Like I have seen many people when they start learning recursion, they, it's like little bit difficult to understand for them, and most of the time when they're referring some tutorial or something from some video from YouTube, usually like you will find like they start with Fibonacci series or factorial to make you understand recursion. But that is like I think this problem, like this problem will be kind of like good understanding. If you do this problem, it will be kind of good understanding of the recursion. So let's jump to the problem. So let's see what problem statement says here. So if you see here, the problem statement saying that on the first row we write a 0. Now in the every subsequent row we look at the previous row and replace each occurrences of 0 with 0 1 and each occurrences of 1 with 1 0. So let's jump to the explanation part here. If you see here explanation, row 1 0. So first row we write 0, the second row we convert 0 to 0 1, the third row we convert 0 to 0 1 and 1 to 1 0, and fourth row we convert 0 to 0 1, 1 to 1 0, 1 to 1 0, 0 to 0 1, and like this it will go on, right? So our problem is to find that kth index, right? So suppose for example we have given two input here, like n equal to 4 and k equal to 5. So if you see here, n equal to 4 means fourth row we have to go, and k equal to 5. So we have to fifth index we have to move 1 2 3 4 5. So this is 1. So output will be 1. So this is what we have to find from this problem, right? So let's jump to the code. So I'll be writing this code in Java. So first let's see what will be the base case here. So if you see here, base case is quite easy. So if n is equal to 1 and k equal to 1, right, so our result will return 0, right? So if you see here n equal to 1, k equal to 1, result will be 0. So this is will be the base case. So we have to write first base case. So without base case, recursion will definitely not work. So n equal to 1 and k equal to 1 will return 0 here, right? Now in recursion, our next step is to reduce the problem. How will reduce the problem? If you see here, our problem, suppose for example we are looking into this set of input, like n equal to 4, k equal to 5. So our problem is this one. So now we'll reduce the problem, right? So reduce the problem means we have to take n equal to 3, right? So let me write here n minus 1. We reduce the problem to n minus 1. But what will be the value of k here, right? Can we reduce k to k minus 1? Okay, let's see. Suppose for example we have given, instead of 5, let's see, we have k is 6. 1 2 3 4 5 6. Here it is 6. Suppose we reduce k to k minus 1 and n to n minus 1. So we'll come here, 6 minus 1 5 and n minus 1 3. We are in third row, and k 6 minus 1 5. You see that there is no 5 index here, only 4 value was there. So k, reducing k to k minus 1 will not work. So what will the value of k here? How can we reduce the k here? So if you see closely here, third row and fourth row, then you will find that exactly half of the value of fourth row is equal to the third row. Means whatever value we have in n minus 1 is exactly similar to the left half of the value of n equal to 4, and whatever the value of the right half is exactly opposite of n minus 1, that is 3. If you see here, 0 0 is 1 is 0, 1 is 0, 0 is 1, right? So now our question is like, how we were trying to find how we'll reduce the k value, right? So if we see, if our k lies in the left half, right, then we have nothing to do, because whatever value will come, whatever the result will come from the smaller problem, that is exactly is the value of k in the larger problem, the our final problem, right? But if k lies in the right half, then we have to get the exactly opposite value, right? If case lies in this half, case index lies in this half, then we have to get the exactly opposite value of smaller problem. Whatever the result we'll get from the smaller problem, we have to convert the opposite of that to find the value if it is case lies on the right half, right? So for that, first we have to find mid, because as I told you, a case right left half right half, left half right half, how we'll find, we have to find first mid value. So how we'll find the mid value? If you see closely here, in each row the, the values are increasing by 2. So here the value is 1, so here it become 2, and here it become 4, and it become 8, right? So let me write int mid. So what we can do is that we can use the Java utility method math dot power 2 to the power n minus 1. So why write n minus 1? If you see here, n equal to 4, so 2 to the power 4 minus 1, 4 minus 1 3, so 2 to the power 3 equal to 8, right? This is, I got the total value in the row, whichever current row I am in, right? So now we have to find the mid. How will find? By 2, right? This is what we have to do. Now, as I told you earlier, that we have to see like whether k lies in the left half or right half. If k lies in the left half, then it is quite simple. We don't need to do anything. Whatever the result we get from the smaller problem, we have to return that problem exactly, right? We have to return that value exactly for the final problem. So we'll check here, if k is less than equal to mid, I mean it is in the left half, then we can simply reduce n minus 1, and k will not going to reduce, because k will be same. We are just reducing the n value, smaller problem. So whatever result we'll get from here, we'll return that one as a result. This will return. Else, right? If else it is lies in the right half, then what we'll do, we will have to go n minus 1, and we have to look into this part, right? This part we have to look. So how we'll do is that, suppose for example, if you see this index is 1 2 3 4 5 6 7 8, this index start from 5 6 7 8, right? So we, if you see this, we are doing exactly opposite of this value to this value, like 0 to 1, 1 to 0, 1 to 0, 0 to 1, right? So to make the index of this value and this value similar, what we can do is that we can do k minus mid here. K minus mid means, so our k, whatever, suppose for example, we are suppose for example k equal to 5 here, 0 1 2 3 4 5, here 5 minus mid, whatever value we mid, here we'll get the mid value 4, so 5 minus 4 1, so it will come here, this value. So this index and this index we can match if you do k minus mid. Okay, that is done. So now I told you that we have to convert the opposite of this value, 0 to 1, 1 to 0, right? We cannot get the similar value as we did for the left half, right? If this case lies in the left half, then we are exactly returning the whatever value in the smaller problem, whatever result we'll get from the smaller problem, that will be returning. But if it is right in the right half, we have to do the exactly opposite. So how can you do exactly opposite in Java? So in Java we can use JOR operator. If you don't know about JOR operator, you can go and read like how JOR operator will convert the value 0 to 1 and 1 to 0, right? And will return it. So this should be our final problem. We are missing semicolon here. I think this should work. So let's try run it. Okay, we got compiled time error incredible to. Okay, okay, we are converting double here. This will return double. We have to convert to int. Hope it will work now. Yeah, that's it. So let's submit it and check if it is exactly correct or not. Yes, yes, it is correct. So this is the final code of this program. Thank you for watching.